Thank you, Jim. Good evening, everybody. And as you heard with Jim, myself and Ray Cross, we're all the Queensland connection tonight. So we're going to do our best for you and have a look at the race to differentiation. And often when you've actually looked online, you've shared resources and looked at education, TI.com, the Australian website or the American website, you come across files, you think, that's a great file. I wonder if I could construct that and work that out. So as you see in front of my screen now, you've actually got a gradient of between 2 points, and you've also got a notes application to the side. So I'll be doing some construction tonight. You may think, yeah, I'll do it a different way, I can do it a little bit better, but there's many ways of doing it. You may have seen it before, but we're going to cover a lot of things tonight regarding construction, working with rates and gradients, and Ray will just wrap it up in the last half of the session and do a few important stuff with materials. So obviously you've seen a file like that and you think, how could I create something like that? So let's open a new document. And what I'm going to do is actually split it in two and make it a little bit smaller on the right hand side of the notes application. I'm going to add a graphs application, and with my window I like to actually construct what that previous file had. So what I'm going to do is actually select the menu through either the calculator or maybe through the menu icon, so I can actually look at the window. I personally like actually going through the window settings, and I'm going to set my window up quickly here. And I'm actually going to get the y-axis of -1 up to 6, the scale of 1, and there we are, they're ready to go. And also we had the previous document, we actually had the dot. So what I can do is pressing menu, select view, grid, and put on the dot grid. That's a good start. So we've got that one there. So what we can do now, we can select a few points. So press menu, geometry, points and lines, and select the point. So let's just pick that point to start with, and possibly that one there, or maybe even this one here, that'll do. So we have that, and I'd like to have a line segment between them. So let's have a look. So through geometry, points and lines, line segment, there we have the line segment. I escape out of that by pressing escape keypad. As we always tell our students, when you don't like something, you want to get out of it, you press escape, you want to escape it. So you see here this previous document that Ray created, that it's a lovely colour of red. So come back to here and you think, oh, it's a bit boring here. So what I could do is right click and actually pick on the line colour down the bottom, and let's pick your colour. So Ray had the red, let's do something different. You might want to do the pink as magenta as it says there, so let's just go blue for the moment, that'll do. So we've got blue. And you think, okay, now we had the coordinates on before, so what we could do, we could actually right click at the point and select coordinates, and we have the coordinates there. Another way of constructing that is possibly using the menu keypad. You think actions, action, I want the coordinates and equations, and I can select the point down there. So let's move the point to the side, press escape to get out of that mode, and let's move the actual coordinates up to here. So what I'm trying to do here is actually look at the actual movement of the point and relate it back to the math box side. I made it just a bit too wide, so let's make it a bit smaller. So we're going to link this with the actual notes application. So what I'm going to do here is I'm actually going to store these values as variables. So if I right click on here, oops, the text, and click to the side. Now, I'm having trouble selecting this here, so here we go. I'll store, there we go, number 5. So that's going to be my Y2. I always tell my students that when I'm constructing with gradients, for example, I like the points high up the page being X2 and Y2. So what I'm going to do now is actually say, I want to call that Y2. So there's a template in here, or you can go through the catalog. So if I go through the catalog, you'll see the last one here with the subscript. So I select that. I might call that Y, and the var underneath there, I might actually change that to 2. Oops, do that again. A bit touchy with the screen tonight, so I escaped out of that one. I'll try it again. So here we go, store, catalog, and I say Y, and come down to here, and if I delete those, I say Y2. I've stored that. So let's have even more success with the text. There we go. I can store that. Now let's try the templates. There it is there. Let's call that X2. Happy, happy, happy. Very good there. So here we go down here. Could have done this beforehand, but some people of the audience may actually want to know how to do this. So do the same thing again. Be very careful. This will be Y1. And then we come over to here and look at the X coordinate. Do the same thing again. And we have X1. Fabulous, we've linked them all. So we've actually stored these. So what I can do now, with the previous document, I can leave the coordinates there, or I can actually hide them. So what I can do, I can right-click and hide them. So at the moment, let's keep them as they are. And we've stored them as the variables. So what we need to do is actually see this pretty document. You see there's actually a triangle underneath it. So let's have a look. So the easiest thing to do there is actually do some construction. So what I'm going to do is go to Geometry, Construction, create a perpendicular. So I'm actually going to perpendicular from here through to the x-axis, and I'm actually going to have from that point to the y-axis. Now if I press escape, so at the moment we've got the lovely perpendiculars to each of those lines forming the right angle triangle. So I'm actually going to have a line segment through there. So under your menu, Geometry, Points and Lines, there's a line segment. So I can actually click on the point, move to the intersection point, there's a line segment, and if I go from the point to the intersection point, we've created our line segments. So we don't want those perpendiculars anymore, so what I could do is actually right-click, we can hide those, click on the perpendicular, right-click and hide, and see that point there, you think, oh, it's a bit too much there, so what I can do, I can right-click on that, select its attributes, and I can change that circle to a cross, open circle. So what I'm going to do is actually keep looking using the right arrow key till we actually have a little thin dot. Happy. So let's have a look at the triangle. So if I grab the point, move it around, still a triangle. So what we could do, we could actually go to the line segment, right-click attributes, and if we use the down arrow key once, we can actually change it to a dashed line. So we're happy with that one. And right-click there, attributes. Same thing for right, down arrow key, right arrow key, until you're happy, and there you have your triangle. Slowly getting the construction done, so we've got that there. So we've got that. So over on the right-hand side, we want to link between the graphs application with the notes. So over on the right-hand part of the screen, what I'm going to do is add a notes application. So in this here, if you press the menu keypad, you'll see that I could actually insert a math box. And you know that to insert a math box is a shortcut there that we have the Control M. So we insert a math box. So what I'm going to do now is insert that. So I'm going to say the gradient, for example, is going to be defined as, so if I use Control, the template, as now I need an equation here. So I like using the fraction template, so I use Control Divide. And we've already listed the variables, so let's have a look. So here we go. Variable y2, subtract variable y1 over the variable x2, subtract x1. So no mistakes so far, Jim, I hope. So it's all good there. So if I press enter, the gradient is 1. So if you look at this here, we can see, if we look traditionally with the junior school, if we look at grading between 2 points, we've got a rise of 3, a run of 3. What if we just actually come back to the graphs application and move it? It's dynamic. So we can actually move the points around. We could actually try the 0 gradient, the negative with the fall, and it's very nice construction. So I quite like doing something like that with students, and students constructing for themselves, and we all do it at our classes, I hope. And sometimes we're just short of time, we can move the points. But obviously, if you go back to the first file, you'll see we've got other construction here. We can keep the measurement on here. So if I grab these points, you'll see that everything changes, so we can do the measurement. So I could come back to here and say, hey, can we do a measurement of the length? So go to geometry, we go to measurement. I can actually measure the length of the line segments, but that's another thing altogether there. Now, next one. So I'm going to insert a new document. I can come up through here to file, or possibly just insert a new document here. I'm going to add a graphs application, and I would like to actually show the value of E, like to do the graphical approach to derive the value of E for the exponentials. Some people use the financial mathematics, some people use the graphical approach. I like using the graphical approach. So what I'm going to do is actually insert a slider. So here we go. So I'm actually going to say A to the exponent of X. And when I press enter, in the new operating system, we've got a new menu to create a slider for A. So, okay, let's do that then. So, and create a slider for A. And we have the slider that comes up automatically. We can move it around. It's up to the individual, but what I like to do is right-click and look at the settings. So, at the moment, as you're aware, I like actually starting with a function of 2 to the exponent X and find its derivative. And as you know that if I actually keep changing the value of the base, I can actually find the value of E. We can use it as a graphical approach. So what I'm going to do is tab down, make the value 2, and make the minimum 2, maximum say 3.5, put the comma there, and step size, let's go up 0.1, tab. As I said before, personal, you might want to say have a horizontal slider, the vertical. I like the vertical slider, and I like the minimized, and then I'll just move it to the side here. So at the moment I've got my exponential 2 to the exponent X. Now the window, we don't need this all down here, so what we could do is change the window. You may be aware, but if I double click on the one of the window settings, I can change it. So what I might do is actually go -3, and as you may be aware, if I press tab, I actually move around the graph and construct the graph. So I might say 8, tab around to 3, tab around, and say possibly -1, and there we have our 2 to the X curve. So at the moment, if I just change that, it will say 2.1 to the exponent X. So you think, all right, so I need to find the derivative. So if I just go Control G, the shortcut to get it back, and I want to find the derivative of 2 to the X. So instead of that there, what I'm going to do is actually either use the template through here or possibly the catalog, and you'll see that we have the derivative function, and we want to find the derivative with respect to the first function. It's a defined variable. As you're aware, you've seen it's F1, so I can just type it in, F1 exponent. So it's X there, so I just press enter. So we have our derivative function. So we have the slider operating. So here we go. We just keep pressing, and you'll notice, and the students will see that the derivative is approaching the function, and then eventually the derivative has gone past. So we say to the students, hey, is there a special value where the derivative of the exponential is the same as the original function? And we investigate it further, so we can actually do this graphically. I know then we can go to the listen spreadsheet and actually do it numerically, then we can do it algebraically. So it's just looking about the sliders. And another one we could do is actually, a lot of teachers like to look at gradient functions. So with a gradient function, we might want to, say, look at a file, and as you may have seen, if you've done some investigation, you may have seen on the Australian website that with the senior inspired curriculum, actually math methods is actually there's files, there's PDFs and there's TNS files based on something like this. You might want to create that file. So I might want to say do a graphical approach to a derivative of a function. So I'm going to, let's have a look, insert a new handheld. what I'm going to do is actually add a graph application, and I might want to actually find the derivative of, say, x squared minus 3x. Let's have a look and go plus 1, for example. So we've got the function, and we want to actually look at the gradient function or the derivative of that function. So what I might do here now to keep the screen clear is actually hide that. So by right-clicking and pressing hide, and we want to link this here to a listen spreadsheet and graph it. So what I'm going to do now, I'm going to actually use the menu keypad now. I'm actually going to press geometry, points and lines, and point on. So let's have a look, maybe there. Happy. Press escape. We've got our point on there. So obviously with our particular function, I want to find the derivative at a particular point. We've got that point there. So what am I going to do? Like before, I'm going to store the x coordinate. So right click, store it, and I might call it the x coordinate. So I'm going to refer back to that. Then what I can do now is actually hide it. It's all there. And now we need to find the tangent. So likewise press menu, or possibly go to the menu keypad, geometry like before, and we have points and lines, and we have the tangent at the point. And it's lovely that we've got the point there, so if I just press escape, that when we actually move the point, we've got our tangent function, and it's given to the gradient. So at the moment, I'm doing a lot of hiding tonight, aren't I? So let's hide that there. So we've got our tangent. So obviously you saw the gradient before, so what I can do, use a lot of measurements, the menu, measurement, and look at the slope. At the moment, our slope is 0.484. So we can say to ourselves, okay, so we've got the gradient, so I need to store that. I need to work with that. So the same thing before, I can actually right-click, store that. This is the way that I do it. So I might call that the gradient and press enter, and then I can hide that. So as I said before, hiding it again, so it's all there. So keep the screen nice and clean. So we've got that. So I've actually got a point. I can move it. The gradient's changing, so I can link it a few things. So what I'm going to do now is insert a distance spreadsheet. And what I'm going to do is collect the data and look at the x value versus its corresponding gradient of the tangent at that particular point. So what I'm going to do is say, I can't use x, it's already been defined, so I'm going to use, let's say, x coordinates, that's a new one. And the gradient, call it, say, gradient. Then if I come to here, I've actually can collect the data. So what I like doing personally is pressing the menu keypad, data, data capture, and do it automatically. You can do it manually one point at a time, but for the time tonight, so I'm going to take the automatic one. So what does it relate to? So if I press the variable keypad, it's related back to the x coordinate, and there's our captured point at that x point, and we can do the same thing for the gradients. So I'll use the menu keypad now, data capture, automatic, and what it's relating back to, press the variable keypad, it's relating back to the gradient, and there we are, 0.484. Wasn't before for significant figures. The rounding on the graphs application was 3 places just before. So we've captured all that data. So at the moment I'm linking the graph back to the listen spreadsheet. So what I'm going to do now is I would like to create a scatter plot based on that particular data. So in the graphs application, menu, graph entry, create a scatter plot, and remember very careful what the variables are. So we have the variable, we had the x coordinate, you can just press tab down, and the variable keypad was the gradient, and if we press enter, we've actually got, at that particular moment of time, we've actually got the point on the function and its corresponding gradient value. Now, some students may get confused with this. We've actually got a y versus x graph, but we're going to superimpose a gradient function so that it'll be y dx or f dash x or y dash on top of that. And what's going to happen now, if I grab my point and do it ever so slowly, I could animate it, is grab it. So at the same time, I'm actually creating my gradient function. And obviously the students will look at that and say it's a straight line, so what could we do? So we could say maybe we could actually input the equation. So if you go Control G, it says it's scatterplot mode at the moment, so what I could do is say, go back to menu, we need to go to graph entry, go to function, and then we could actually type in the function and see what it is. So let's pretend we get that wrong. So what was it? 2x plus 1. Obviously it's wrong. So maybe the gradient's right, the 2, but the actual constant term is plus 1. So there's a nice way to construct a diagram between linking applications, talking about rate of change leading into senior school. Now, there was a file that you may have seen before. The same thing that I've got here is actually I've got the sine function on the top of the screen, and the bottom half I'm actually going to do the same thing, create the derivative function. So you'll see that just before we've got the coordinates. But if I just go back to the previous document that I've just created, when you're here, another thing that I like doing is actually keep doing it again. If I click into here and then press enter, enter again, I've actually just gone back to one point being captured, and I could do it again. I could change the function, and you'll see that the actual point of the line refers back to the gradient functions. That's a nice thing you can do in your construction. So in the derivative of the sine, what I've got here, and you think, oh, sine function, shouldn't I actually have the axes using the radian mode? So what I could do is here, I could actually come into my window, and what I like doing is actually think, well, that's negative pi. So if I just go negative pi, I often use pi, or sometimes I use a pi template. If I tab down here, that looks like 3 pi, so I'll just go 3 pi. And scale, maybe what do the scale do I want to use? Maybe pi over 2, so I'll do pi divide 2. And if I press enter, looks nice, doesn't it? So we've got our radian measure on the y-axis, not on the x-axis. Then the corresponding graph on the bottom, you think, look at the actual labels. You think you've got y, you've got x. What I could do on the bottom half is actually change the label. So if I double click, what I might want to do is actually just do f dash of x, and then I've got my derivative graph and the correct labels, and like before, I could actually grab in the first part, grab that and create my gradient function down below. And like a lot of things, we can look at that with the students. We've created our own function, and we've actually got the gradient function, so the students can see down below possibly what could the gradient function be. So looking at the time, conscious of the time, so Jim, I think I'll finish up there now, and hope that's okay with people tonight, showing how to construct certain documents. There's plenty of other documents you can look at that are part of the line, so I'll finish up there now.
Thanks very much, Rodney. There's a lot to consider there, and lots of useful construction techniques, and we'll hopefully pass straight over to Ray with a few little, and avoid the few little technical problems I'm having at my end here that I've just about sorted out.
Okay, thanks, Jim. I'll just share my screen now. Hope it'll come through shortly. Are you seeing screen now?
We've got it, Ray.
It's coming through now.
Okay, that's great. Beautiful. Thanks for that, Rodney. Jim, basically, I'm just going to concentrate on developing what Rodney did with some of that school stuff and put in a little bit of a practical aspect. The first little document that we've got here is just a document that really makes use of a facility on the TI-nspire with respect to quantities. I think it's important that we don't really just look at a rate as being just between a couple of numbers, a fraction, one number divided by another. It really refers to the ratio between two quantities, and you can actually do this on the TI-nspire. This is a notes page. We'll do this in a minute. And you can see down here you've got a maths box inserted, as Rodney explained. And this is dynamic. We've got 20 degrees centigrade, and that's divided by 4 gram. So if we change that to, say, 120 and press enter, you can see that it converts it into 30,000 degrees centigrade per kilogram. Now, it's important to realise that the calculator in this case is set to SI, or Standard International Units, so therefore it's degrees centigrade per kilogram, so it converts it in that way. Now, the way in which we can do that is pretty straightforward. All we'll do here is just insert a notes page, and within a notes page, as Rodney explained, we can either just insert a maths box, or you can press the shortcut Control M. So insert a maths box. Within that, what we're going to do is insert a fraction, and then there's a couple of ways in which you can get that underscore in. Let's think in terms of a road construction company that's producing, say, I don't know, 150 kilometre of road. So to get the underscore, press Control space, and we just need to type in kilometre, so just km. Then down here, it's producing that in, let's say, 2 years. So to get years, the other way in which we can access that is to go to the catalogue. In the catalogue, you've got all these tabs. Tab 3 gives you constants and also various units. So if we come down here to time, open that up, and down here just highlight on year, press enter, paste that in, press enter again, and it immediately converts it. So that's a good little application, junior school through to senior school, to make sure you keep reminding students about the fact that when we're talking about a rate, we're talking about quantities. We're talking about a ratio between quantities. We're not talking about just rise over run, or delta y over delta x, or whatever it may be. It's actually the change in the dependent variable, which is a quantity, divided by the change in the independent variable. So in order to illustrate that a little bit more, if you've got a CBR, and I suggest you really should get one of these, a calculator-based ranger, which uses ultrasonic motion. It's an ultrasonic motion detector. So there it is there, connected to the Inspire CAS calculator. You can also connect it straight to the PC, which is what I've done, or laptop, which is what I've done. Now, I won't go through all this because we haven't got time, but basically I've got a data here. I tried to match this, which is what we're going to do. So I will just get rid of that. So down here I'll strike that data out in that selected region. So this is the position match running from 0 to 5 seconds and up here to 2 metre. We'll just create a different one. So go around there to motion match, a new position match. Okay, that looks fine. Now I'm going to connect, hopefully this will work. I'm just going to connect my CBR, and when I do, what should happen is this should change to green, hopefully. There we go. Now what I've got to do is to try to match this, and I'll just hold this close to the microphone. You should hear it clicking. Hopefully you can hear that clicking. Now what I've got to do is hold it pretty close to 2 metre away, and then move it towards the floor, and then just move it up slowly, and then move it up much more rapidly to around about 1.5 metres. So we'll see how we go. I'm not too confident of being very successful with this. The cord tends to get in the way, but we'll give it a try. So up here at 2 metre. Right, pretty rough, but with a little bit of practice you get the idea. Now the basic thing about that is I think that gives you a really great hands-on approach. Students grab the CBR, they've got it in their hands, they're moving it, they get an idea of rate of change of position with respect to time. They mess it up like I just did, do it again, and obviously try and get in this little section a constant rate of change of position, a different constant rate of change of position there, and then a third different constant rate. So it's giving them a hands-on bit of experience to appreciate what rate of change is all about. Moving along then to this document, you saw that with Rodney. That's a document which obviously is worthwhile constructing, and I certainly agree with what Rodney did, that you get students to construct that. I'd like to have a look at this one, and so what we'll do is construct this little document just to move on to what average rate of change is about and try to illustrate that. So I'll just insert a graph page, and within the graph page we'll just do as Rodney did. We'll just view a dot grid like so, and then I'm going to insert a few segments. So we'll just go perhaps from there to there, and then from there to here. We'll make it pretty simple from there down to there, and then let's do another segment anywhere at all like that. This one we'll just change and make it a little bit thicker, and then also I think I might change the colour to be red. So there we are. One of the things that tends to happen is with the points, the drivers tend to be, I've noticed in most of the documents that are being used by people, tend to be empty large circles. So if we're driving something, then it's a good idea to get into the habit of making these empty larger circles. So this one here, we're going to label that as S, and this one up here, I'll label that one as F, and S stands for start and F stands for finish. Now what we need to do, like Rodney mentioned before, is we're going to measure the slope of each of these segments, including this one here, and then we'll just escape from that. And then if we move this down here to this start position and move it to there, quite obviously you can see that the slope, the gradient, the rate of change, if we put appropriate quantities on each of the independent and dependent axes, is the same, it's 2. Then if we put it there, we notice that the rate of change between the start and finish point is equal to 0.6. But of course, the rate of change of each of those segments, 2 and 1 respectively. If we move this one down to here, the rate of change between the start of finish positions is equal to 0. And the really interesting thing about that, and I get students to construct this themselves, is that if we move these points around, then clearly we can change the rate of change, the gradient, the slope of each of the segments, but of course we notice that this stays the same. If we move that up to there and we move this point around, then of course the rate of change, you can go down into the negative area if you like, but the rate of change over the whole journey from start to finish remains the same. One nice little feature of the last operating system is what's called maths draw, and if we started from there and if we just followed that position time graph, if that's what it was, through to the finish, then between the start and the finish positions, the rate of change is still equal to 0. So I think that's a pretty useful little document that students can create that might help them to understand the idea of average rate of change or average gradient. When I was messing around the other day with my mobile, I actually was looking at the BOM site, the little app for the mobile phones, and what I came up with was this little graph of the change in the temperature over time and the change in the humidity over time at the gap in Brisbane. Unfortunately at the moment it just seems to be going up, the humidity is terrible. But anyway, that's what it was a couple of days ago, and let's look at seeing if we can create this and how we can use that. So what we'll do is take the image of the bomb site. There it is. And if we just do a snip of that, which I've already done, copy that, and then come back in here, and we will insert a geometry page. Now, you might wonder why I'm inserting a geometry page. The reason is that when I paste in that image, it obviously is pretty intense, and that means if we want to put a modelled line over the top, which is what we'll be doing, it's going to be pretty crowded and might be difficult to see. But clearly, we want to look at the graph, and when I convert it into a graph page, the image just fades a little bit back into the background. That makes it a lot easier to overlay a line or whatever you want to overlay on to the top of the image without the whole thing getting too crowded. So now let's look at inserting a line this time. I'm going to go for a line, I think. Might be the best way of doing it. So just anywhere, doesn't really matter. There and out to there. And we'll escape from that, and we might just change the thickness of that, and also just change the colour into red. The other thing we've got to do, of course, is take this point here and move that back up there. The thing that I didn't do is to change the axes, and what we want to try and do is see if we can match these axes to the grid that we've got there on the bomb site. So if we do that just by going to Menu, Windows Settings, in here we'll make that say about -4, and then tab down to this one, and we'll make this about 25, tab down to there, and it jumped across in intervals of about 3, I think, and tab it down to here. We'll start that at -5 and tab to a Y max of around about 40. We can adjust it in a minute. Tab it down there, and I think that jumped up in marks of 5. So that's pretty good. Just move that around just a little bit. So it looks like that. And one little trick that is probably worthwhile knowing is that if you just highlight an axis and hold down the Shift key, I think Peter Flynn or Russell Brown showed me this at some stage, you can just move one of these around, one of the axes scales around, just adjust them like that. I'm not going to fiddle around with that too much, but we'll move this point up to here, and we can move the line around there, and you can see that it matches that first segment, first 3 hours or thereabouts. And if we look at the coordinates and equations of that graph, you can see that this coefficient of x represents the rate of change of temperature. If we change this to degrees centigrade, of temperature with respect to time, where time is measured in hours. We can grab this and we can pull it down, and of course it's all dynamic, like so. One of the new features in 4.2 is if you go to Menu, Graph Entry, Relation, you can type in here something like x equals, say, t, and press that, and there it is. Obviously, we might just change that one. We'll just delete that because t has already been defined. So basically what might happen here is let's delete that one again. So Menu, Graph Edit, Relation. So let's put in x equals, say, t, mm, something like that. That'll do. Enter that. And as Rodney showed you before, you get a little pop-up window to create a slider for that parameter, which is okay. What I like to do is to look at the settings. Settings go from, say, 0 and we want to go, let's make this say 5 at the moment, a maximum, go up to say 24 hours, something
So
like that.
Ray, you still got a value
Yep.
of 10 at the moment. You okay with a value of 10 to start with, or 0? What did you want to start with?
Yeah, I think 10 will be all right. We'll just put it in there and just see how we go. We'll just minimise that. Yeah, thanks, Rodney. Yep. So there you go. Just move that across here and just escape from that. We didn't want that one. You move this, you can go backwards and forwards. Now, what you can do here is you can look at the intersection. You might be interested in looking at the intersection of that line and that relation, and then as you saw with Rodney, you can get the coordinates of this intersection point there, like so, and you can, let's just escape from that for a minute. We'll just grab the text and move that out of the way, I think. Move that text over here, grab the line, and you can move it around, and you might want to just change this back like that. Grab this line here, move that up to there. Just seem to be losing that point, but I think you probably get the idea. If we run this across here, we move this point, grab that text, just move it up a little bit, move this point, extend it, just grab the line, move it down a little bit, and move that across there. You might be interested in times, say, 18, so what we can do here is change this, make it 18, press enter, and now you can look at the fact that if we do that as the start point, you can look at what the average rate of change, which is shown by the coefficient of the x term in the linear function, has been over this time interval. So that's a nice little way you can play with that and do all sorts of nice things. Now we're beginning to run out of time here, so basically Peter Fox was talking about the old chestnut of when you're filling a vase with water. That's on the site, the Australian site. So if you go to Teachers Senior Curriculum, then within the senior curriculum, if you tab on to Victoria and Maths Method Year 11, in there, the calculus, there is this little document here, and some of you may remember, certainly I think Jim would remember back in the 80s, I think it was, there's a applet out of Japan, I think it was an IS site that did something similar to this, and this document here has got a PDF file for students, also answers, and also a TNS file. So let's have a look at the TNS file of what's going on there. You've got this information here, you can investigate it all. The beauty about this is that you can change the shape of the bars and look at what happens with the height versus volume graph as you change the shape of the vase. So what we'll do is just make it pretty much like a bucket, something like that. So you obviously pretty much get a curve, maybe a quadratic. You can do all these sorts of things. So clearly maybe a cubic or something there. Clearly it gives you a great idea of rate of change of height of the water with respect to volume. Talking to Peter Fox a couple of weeks ago, he mentioned he was trying a CBR and trying to look at constructing some data points for a bucket, filling it with water. I tried it, but as you can see, not very successfully. What I did is I had a bucket with just a little plastic top off a takeaway container, and on the top of the bucket I had a plank with a CBR sitting on top of that. Just took a few data points. So that's what happened. Then the other one I tried with a carafe, and this I didn't have to empty it before I tried the experiment. Fortunately, it was filled with water, and I might have to repeat that. Might be more successful if it was filled with something else. But anyway, when we look at the CBR recorded data, here we've got the bucket being filled from pretty empty, and clearly it's going down because the water level is increasing. Around about 2/3 full, it's looking like that, and this one is pretty messy for the carafe. So we'll have a look at the second one when it's 2/3 full. There's the data, and what we can do with that is we can send the data to a list and spreadsheet, and we've got run time 1 and we've got run one position. Now that's not going to work because what we want to do is look at the height as the height is a function of time. So you notice if we come back here, a little bit messy, but it goes up to about 0.16. So what we might do here is we might just insert a column, and then in here we'll probably just call this just say height, and down here we'll make that 0.16, and we'll take away from that the run 1, got a few things on here, run 1 position into that, like so, and then we can do a little, let's make it a quad regression of the run 1 time is on the independent variable, and on the y variable we've got run 1 height, I think it was, run 1 height. Let's paste it to F1, and that'll do. First result column will do there. So it's going to override a little bit of data. Now we'll just insert a graphs page, and in the graphs page let's have a look at scatter plot to start off with. So in variable for the horizontal independent variable run 1 time, down here is going to be run 1 height. So enter that and zoom into the data. So it looks like this. Go back to the function and insert, so I've done a few of these, insert F1, I think we made it. So there it is, F1 looks like that. And what we can do then is we just simply maybe look at the instantaneous rate of change, and to do that, menu, geometry, points and lines, whack on a tangent, extend this, and the height against time. So you can do a whole lot of other things with respect to that, but I really think that probably what I want to do now is just move on a little bit from that one. So we'll go into something that might be a bit challenging for a lot of staff, is to get students to use their phone to collect some data rather than talking or texting. So if they can stop talking and texting for long enough and they let their phone discharge to about 15%. I actually collected this data the other day because what I was concerned with or interested in was the fact that it seemed to me in charging the phone that it tended to charge at a slower rate at the top end of the scale. And if we have a look at this data here, you can see that discharged to 15%, you can see it's sort of jumping in intervals of 11, 12, that sort of stuff early on. But then when we come down towards the fully charged, in these intervals, these 10-minute intervals, it's jumping in at a decreasing amount. So I thought that might be interesting to have a look at what happens there. So let's insert a graphs page, and we'll just look at scatter plot, and in here I think we've got time and percentage charge. Okay, so in there, variable, so we've got somewhere down here time, and down here the variable is percentage charge, so enter that one, and can't see much, so we need to zoom data. There we go. Interesting. So go back here. What we might do here, I think, is do a regression. We might try quartic. So xlist is time, and the y-list is percentage charge. Let's put it in F1, and can go in column C, I think. Whack it in column C. Okay, so R squared value looks really, really good. Coming over here, let's just pop that in to the graph. So we'll go up to F1. There it is. So you get that nice little match between the data and the regression equation. Now, what I'd like to do very quickly here is just to draw in a segment again. I know that's a bit boring, but it's just going to relate to a little calculation. So we'll do a segment from this point up to that point there, and then what we'll do is just measure the slope of that, which is equal to that, and then we might measure we won't do that, sorry, what we'll do is we'll just go to actions and get coordinates equations of that point and also of that point there. It's getting a bit messy, so let's just hide that. Now, notice that what happens here is that across the time base of 110 minutes, it's increased by 100. So basically the average rate of change here is 0.765. So what we should see is 0.765 multiplied by 110 should give us the plus the 15.8 should give us the value of 100. So just insert a calculator page. So in here we've got 0.765. We multiply that by the 110 and we add to that 15.8, I think it was, and you can see it virtually gives you 100. So that's just a little example of just linking. We're just going to show a couple of other documents. Again, one of the fantastic, absolutely fantastic hardware that you should really have is a lab cradle. There's a little image I took of a lab cradle with a light detector here on the left and a temperature probe on the right, and that's really great. You should have one of those because it's fantastic, not just for this, but collecting all sorts of things. So I used the light probe with the lab cradle and tried to replicate the inverse square law Basically down here we've got time, so all I did is just had the light probe. I just actually used the torch on the mobile phone, just moved it away at a constant rate. So if you just rescale this time axis, if you just multiply it by the speed with which I moved the light source, the actual probe away from the light source, then that would give you distance, and you can see it's pretty much an inverse square law. So without going through all the stuff that we did before, you can see you get that sort of result. Another thing that I did here, very quickly because we're beginning to get pushed for time, is to do a little trial using CBR again. And here we're just putting, this is data collection 5-minute intervals, just simply putting very hot water boiled in the kettle into a mug and just letting it cool, 5-minute intervals. Same sort of thing, putting into a freezer. And this one here was much more interesting, which is just a mug or a vessel of liquid water in this case, placed into the freezer, and see how long, with the probe in there, a temperature probe, and see how long it takes to cool. That one's going to need a little bit more investigation, and I don't think the liquid will be water, and we'll just see if we can get that right. So that's rather interesting. Secant, you've got this file here. We just haven't quite got time to show you that one. I think you can probably follow that through given what Rodney's given with you. What I would like to show you just to finish up is this one here, and this is how you can use first principles in a notes page to step by step, and students can check that they're doing things correctly. So let's see what we've got here. If I were to change this to a 2 and press enter, then it's all going to be dynamic, and you see you've got the graph over there. So let's see if we can replicate that. I'm going to insert a new document, and in the document we'll add a notes page. We will insert a maths box, and in the maths box we're going to put f1 of x. Actually what we might do, and we'll define that as being, make it simple, to start off with just x squared, press enter, so that gives you that. The next maths box, just by pressing enter, you insert another maths box, just try f1 bracket x plus h, wherever h is, that's great, press enter, that gives you that. Now, next one is we want to look at f1 x plus h minus f1 x, so just f1 bracket of x plus h, where's h, there we go, and we take away from that f1 of x and press enter for that. That's okay, but sometimes if you have some other function up here, you might want to put another maths box in here which expands that, because most students in doing that would have it in the expanded form, and sometimes it's actually in factorized form, like for instance this. If we put plus 2x in there, press that, then you can see what happens is it factorizes it. And students might not recognise that. Certainly my students tend to have problems in putting in that extra step, and that's usually all expanded. So in here, in this maths box, if you actually went to algebra and put it in expanded form and then had this, so we'll just do a Control C for that and whack it in there, press enter, then that's the expanded form. Now, next maths box we want to find, we want to define the, by first principles, the derivative of the function. So I'm going to call that f2 bracket x, and that's going to be the equal to, in here, the limit, so just highlight that, of h, as h runs to 0. We can put plus or minus in there, or why it's not going to make much difference. In here, we're going to put our little fraction, and in the numerator, we actually want that. So put that in there, and down here we want h, and press enter, and there's f2x down there defined to be equal to that. If we come back up here in the new 4.2 operating system, if you right click on that, you can graph that. There it is. And while we're in this section of the page, if we go to function, we can put in F2. Right, so actually the trouble with that one was we actually didn't define it. So basically what should happen is if you just defined it, then you could graph the derivative function in there as well. So I think, Jim, that probably pretty much covers it. I know I've run out of time, but hopefully we can. Yeah, I think that's pretty well it. I just make sure you define this here. I didn't define it, I just put that in. So yeah, if you did that, it would work out all right. You could graph that. So yeah, we're well and truly over time. So hopefully that gives people something to work on and helps them in students understanding rates to differentiation.
Thanks very much, Glenn and Rodney. It's been a tactful presentation. Obviously you have lots and lots to share. Now I'm just making sure that I am actually online and working this time, and I can see that if I share my screen just to finish off and see if it actually works, just while that's happening, I just explained that there was a little bit of a problem at the start. I had the experience where the wonderful Windows product decided to force an upgrade on me a few minutes just before the webinar started, so I had to log in on a different computer, and a few things happened, and then finally went through all the upgrades, got back on this computer, which was just as well, because Windows then forced the upgrade on the other computer that I logged in on. So I'll just remind you that because these guys had so much to share, that in a few days' time, this webinar will be on the website. Just make sure you go to the Texas Instruments website, make sure you're in the Australian-New Zealand site, click on webinars, and you'll find the on-demand webinars. And so I don't want to go to that. I want to stay here and go to that one where I've clicked on that already, and you'll see the on-demand ones where this one will be. And there's a couple of upcoming webinars listed there for you. You're going to get quite a dose of rates and calculus in the next few weeks for these webinars. This one looking from the point of view of the calculus as it applies to the IB curriculum in those schools that are running it. But it's, whether it's for IB or any other course, it's always interesting to see how other people treat these topics, and I'm sure we can adapt them for our courses. So folks, thanks very much again to both Rodney and to Ray for their time tonight. We're well and truly out of time, but I just point out to you that there will be the link on there for you to get your certificates for your presence here tonight, and we do value your feedback, so if you'd like to follow up afterwards and take the time to complete the survey, that would be great. There was lots and lots of information passed on to you during the time while you were waiting for this broadcast to begin, so hopefully you've looked at that. There's a couple of PDs coming up in various parts across the state. If I could just find one here and skip through. Let me see if I can find it. There we go, that one. Learn, Energise, Connect next weekend, the week after next rather. No, next week, Friday. In Brisbane. Yep, this Friday, a week's time basically. There's a bloke called Jim Lowe and Peter Fox presenting that one, so love to see people come along to that if you're in Queensland. And you'll also find lots of links there to where you can catch up with the TI people at Maths Association conferences right around the state. And if I can be parochial and plug the Queensland one, 25th and 26th of June. And I think that just about does it for me, folks, because we are well and truly out of time, and we're going to start soon. We're finishing. Please go to the website or use those phone numbers if you've got any questions or follow-up from tonight's webinar. And that's it. We'll close this broadcast now. Thanks very much. Bye, folks.